I'm an engineer with Toast, based in Boston, but I work in the Dublin office, so I'm over here for this, so it's really awesome to see the Kotlin community in Boston. I've been working with Kotlin for about a year and a half, and with coroutines for like the last year. I was a Java engineer before that. So I'm going to be talking to you today about this project that I've been working on. I'm kind of part of this where we use coroutines to clean up this third-party async API. So we all know asynchronous code can get really messy really quickly. Callback was named so for a reason. And there's lots of good ways to avoid this in your design, but sometimes you have to live with an async API that it's too difficult to work out when you write, or it's provided by a third-party API, or it's a third-party API that was the case with us. So Kotlin Coroutines turned out to be a fantastic way to clean up this API. They made we could build an async API that looked as easy to use as sequential code, sequential blocking code, but we could give us all the benefits of non-blocking async code. So yeah, like I said, my name is Tom Hanley, software engineer at Toast Dublin. Also organizer of the Dublin Kotlin user group, and a huge fan of Kotlin. Right, so quick rundown on coroutines. So I'm not going to go spend too much time on the introduction. So who here has used coroutines before? Just to who here has kind of some idea what they are? You do? Okay. Okay. So essentially, why you use them is because threads are expensive. So they're essentially kind of lightweight threads. You can think of them like that. They're conceptually like that. You can kind of treat them like that. Threads are expensive, and they take 1 to 2 megabytes to create. So you need to manage them with thread pools. It gets a bit awkward. Coroutines, they kind of look and feel like lightweight threads, but what they really are is state machine objects. So it's a block of code, and you say, run this, and the state machine object has the data for each state, the index of the current state, and the ability to wait patiently. So when you think of them as like objects with certain code to run and the state of that code, it kind of makes sense how they're so cheap to create. In the previous talk next door, and kind of on the JetBrains kind of key demo for coroutines, they launched 100,000 coroutines, and this works fine. You launch 100,000 threads, and you get it out of memory very quickly. So yeah, these small objects are really cheap to create, and you can distribute them to run on threads, whatever thread pools you have as normal. So they're the new Kotlin 1.3. It's not a new concept. It's been around since the 70s, I think, but it's a really nice pattern. So there's 2 ways to create a coroutine. Launch is when you want to fire and forget. You don't want a result. Just do this work, and I don't need a return value. Async is used to create a coroutine that computes some results, so you want a return value. These behave a little bit differently in terms of exception handling, which I'll run through later on. So the case study. So I'll tell you a bit about Toast and the project I was working on, the problem we were faced with, and how we use coroutines to solve the problem. So Toast is a restaurant company. I'm sure a lot of you from Boston or the US might know them already. They're in a lot of restaurants around here. So we're a restaurant company. Our core products are cloud-based point-of-sale system and credit card processing. So all of our in-restaurant technology is on Android tablets. So when you're in the restaurant, the server is putting in your order. This is the tablet. You can see the mouse. The credit card reader is attached. We have like handhelds that you can bring around the table. Kitchen display unit that displays the tickets coming into the kitchen. And then a web backend for config reporting, as well as a Toast takeout app, like an order ahead app for restaurants. And integrations with dozens of technology partners like Uber Eats and Delivery and such. And so the sales pitch slide. So maybe a little bit out of date, but 250-person R&D team, tens of thousands of customers in the US, processing billions of payments every year. So July 2013, we got our first live customer. And last April, we raised $250 million in the Series E funding at a $2.7 billion valuation. So less than 10% of the US market share so far. Lots more growth to come, and if you're interested in getting involved in this, do get in touch. We have a table out in the foyer. So the project, sales pitch over. So integrating a new card reader. So there's a new credit card reader, a USB connected reader. This is designed and manufactured by an external hardware company who provide us with an Android SDK. The project was to integrate it into the application. So all the calls to the reader need to be asynchronous. You know, they're idle calls, they're going over a USB connection. So this is kind of, at a very high level, what the API we were given looked like. So there's two classes for interacting with the reader. You have a controller to send commands to the reader. You can't get any information back out of this. And there's a separate listener interface that, you know, the events come back through that, or the callback. We implement this interface, and when events, we pass it into the controller, and when results come in, they call methods on this listener interface. So yeah, the controller methods are all void methods, which is a bit jarring at times. You know, there's like getters that are void, and you have to kind of go to the listener to get the value. And then yeah, the listener will asynchronously return the information from the controller. So this might sound okay, you know, kind of ticks the box for being asynchronous, but it's actually very difficult to use cleanly. So we're going to take a look at a small section of the API to illustrate. So basically, the kind of problem with it is, you know, with that completely separate controller and listener interface. You know, when you want to do one command, wait for it to finish, then immediately do another one, and just kind of like chain these commands together. It gets very awkward. So yeah, we'll take a look at a small section of the API to illustrate this problem and what we did to get around it. So a function to get the device info of the card reader. So this returns a data object that contains the battery level, firmware version, serial number, kind of information like that. So these are kind of snippets of the two classes. So we have our controller interface with the get device info, but it's a void method. And then we have this listener interface that we implement. So we have on return device info, which passes in the device info. We have on error if an error happens during this, or if we call it at the wrong time. So what might the implementation of this look like? So we take a look at a naive implementation of the listener interface first of all. So say whenever we get a device info in, we just save it to a field. We do the same with the error. So these are, we're communicating to the outside, communicating outwards from this listener with shared public mutable variables, nullable variables. So some dirty words in that sentence. And then if we want to actually get the device info, it might look a bit like this. So, you know, here's our function signature. It's, you know, it's a getter that returns the object, which, you know, is we kind of need this. And then we call get device info on the controller. So this will, so the void method, it doesn't return anything. Then we need to go to the listener and start like looking, checking for the data there. So we have a while loop, while neither of them, while they're both null, we sleep, so we're blocking the thread. We're hoping that one of these does get set. If we get an error back, we save it to a local variable, we null it out, so this will work the next time, we throw it. And then if we don't, if we get the value we want, we save it to a local variable, null it out on the listener, and return that. So lots of issues here, and we couldn't really live with an implementation like this. So like here, not only we're blocking the main thread, potentially getting into an infinite loop, but like knowing out the listener values as well. And this is the issue with using shared mutable variables to communicate between threads. That you need, if we were like this isn't thread safe at all, if we wanted to make this thread safe, we need a whole bunch of synchronization and detailed knowledge of the JVM memory model. So we said let's clean this up by writing a Kotlin Coroutines extension. I'm not sure how great of a name it is. The extension kind of started off with like controller.ktx because this is like an Android thing where you write a Kotlin library that Kotlinizes the API. But then it ended up calling it extension. Another option was, controller with a K, but we went for extension. So, so this is kind of the API that we wanted to get to with Kotlin. So the result of the query is clearly returned by the function itself, which since there is called referential transparency. The caller of the function can control the asynchrony. The implementation doesn't block the thread. Easy to use, hard to misuse. You know that one call is completed before starting another. So this is kind of the function I wanted to be able to call this. So it's a suspend function. Same as the previous signature I showed, but it's a suspend function. So instead of blocking the thread waiting for the device info to come back, it'll suspend. So the kind of what this does under the hood is there's a hidden parameter here in the device info that the compiler adds, and it uses a form of continuation passing style that kind of says, get the device info, and when it comes back, execute the rest of the program. At a high level, that's kind of some of where the magic is happening, but it's we just get to add the suspend keyword, and it handles all that magic for us. So how might we implement this interface? So kind of at a high level, what we want to do is start listening for an event or error, trigger the event, and then wait for the event or the error to be returned. So this requires a bit of asynchrony and inter-thread communication. So how we can handle this, we can take some advice from the Go documentation. So do not communicate by sharing memory, instead share memory by communicating. So we know that communicating by sharing memory is bad, but what does it mean to share memory by communicating? So this is where Kotlin channels come in. So they're Kotlin Coroutines feature. They're kind of exactly as they sound. They're channels, data goes in, or an object goes in one side, someone else takes from the other side. So this is kind of a rough data flow diagram of the extension we want to add. So when data comes into the listener, we just put it into the relevant channel, and our controller extension can then know where to look for different things. So channels, they're conceptually very similar to a blocking queue. But one key difference is that instead of blocking put and take operations, it has suspending send and receive operations. So it's not blocking a thread. There's no thread sitting there waiting for a response, but it will suspend the execution of the program. It's an experimental feature in Kotlin 1.3, which kind of some people find a bit off-putting, but it doesn't mean it's not ready for production. It just means they expect that the APIs might change going forward. And a big benefit of using a language that is created by the people who create your IDE also is that their auto migration features are really, really good when they have new versions of it. So yeah, let's take a look at our new controller listener implementation. So this is when we have these outward-facing channels. So we're implementing the listener. When we get a device info update, we just pop it onto a channel, and then same with the error. And then, for kind of tying triggering the event and getting the result together, we have this controller extension. So this contains two parameters: the original controller that were provided with the hardware, and also our listener implementation. So when we want to get the device info, we delegate to this method trigger event and get results. So we have three parameters. The event trigger, which is just a lambda, and we say whenever you execute this, you will get either an event or an error, and you listen for them on these two channels. So what does that implementation look like? So here we can see the trigger event and get result function with the three parameters. So the first thing we want to do is start listening on the two channels. So Kotlin provides this really nice, the coroutine library provides this really nice select statement, which means just start listening for these two suspend functions and just give me the first result that you get back. So we say if we get back an error in the error channel, we throw that. If we get back an event in the event channel, we return that. And that gets returned to this this async block in this deferred event. Then we trigger the event, which is the lambda parameter that we pass in, and then we call deferred event.await. So this will suspend until we get a result. So yeah, this select expression, really nice feature with coroutines, so it makes it possible to listen to multiple suspend functions simultaneously. So here we're just listening to channels, but you can use it for any suspend function. And yeah, the kind of result of this is we have a nice API like this. It looks like normal sequential blocking code, but you can see the suspend markers in the gutter of IntelliJ in Windows Studio. So this will make a call to the card reader, wait for a response without blocking a thread. And same with all of these. So we get the device info, we start the USB connection, which should be before getting the device info. Let's see this, and then we can start the transaction. So you can start down here that we can, that I think might make this a bit clearer. So like from our application, the only API it sees is get device info, return device info at a suspending point. So that's kind of the bit we're focused on. But then under the hood, what that does, the controller extension, it will start listening on the device info and the error channel, trigger the event, then actually make a call to the physical reader. That will come back to the listener, it puts this event onto a channel, and we send this back to the controller extension. So yeah, that's kind of the end of the case study part. So I'm going to move on to this kind of the key lessons learned in doing all of this and figuring out all of this. Are there any questions before I move on to this part? Sure.
If you wanted to have a timeout situation, would that go in select? Is that where that would happen? Or?
So we actually have added timeouts. Where is this? We have added timeouts, but I put it around this block. So I've added another parameter, but just kind of didn't want to make this too much code for one slide. But there's another parameter here that's like the timeout, and it'll just use the with timeout block routines here. Cool. So jump into these. So the kind of three main areas of key lessons were exception handling, which you have to do a lot of when you don't know what you're doing. Debugging coroutines, so there's some really good debugging tools that are useful if you don't know how to handle exceptions, and some kind of tips for keeping coroutines testable and clean. So yeah, understanding how the exceptions are handled is very important, because I found some of this a bit counterintuitive. Took some time to figure out some of this, so hopefully some of this will be useful. So structured concurrency, this is kind of a concept they introduced in Kotlin 1.3, where a coroutine has to have a parent-child relationship. So you launch a coroutine, it can launch whatever children you want, but when you cancel the parent, it'll cancel all of its children. So they kind of enforce this in Kotlin 1.3, and they say, avoid using global scope, which is like, your coroutine will run until your application runs. But with structured concurrency and this parent-child relationship, you can cancel a parent coroutine and cancel all of its children really easily. But yeah, what I didn't get is that at the start was that by default this relationship is bidirectional. So if a child coroutine is cancelled or finishes exceptionally, it will cancel all of its siblings and its parent coroutine as well. So yeah, let's take a look at some examples. So here we have, we launch a new coroutine that may throw an exception, as it does in this case. So if we try and catch it like this, this will never be printed. We need to put the try catch inside the launch, which is a little bit different to how async works. But not only will this not catch it, it will also cancel your whole coroutine scope. And it will be treated as an uncalled exception, which on Android will crash your app. So not ideal to be dealing with exceptions like that. And then for async, so it's a little bit different than async. So say we have this function calculating where it's a suspend function that does a bit of work and returns an integer. We have a coroutine scope that it uses. The parent job, which is just for cancellation. If you want to cancel all of the coroutines that are created in the scope, you just cancel that parent job. And it runs on the default dispatchers, which is like the default thread pool that you use for doing computation work. So the first value you try to calculate, this makes wrong exception as it does here. So it's an async block that returns a deferred value. Then when we call await on that, that's when we get the exception. Whereas with launch, as soon as the exception is thrown, that will crash your app. So this will work fine up to here. So we catch the exception and we default to a value of 0. But then when we try to use that coroutine scope again, not only will this not work, but it'll give us the same error as the first one, which is can be pretty confusing. But there's some ways to get around this. So the first one, which is a really good solution, is to use a supervisor job instead of a job, which is kind of, all the examples you look at, just use a job. The starter example, but supervisor job I think is much better. So it means that the cancellation of a coroutine is propagated only downwards. So if you cancel the parent, it will still cancel the children, but not if a child finishes exceptionally, it won't cancel everything. Second solution is to use a coroutine scope block. So you see this coroutine scope block. So what this does is it will inherit the parent coroutine scope context, or the caller's coroutine scope context, but it will get its own job for independent cancellation. So it can cancel, it can throw an exception if it wants, and not affect the parent. So it's good for grouping actions that are all or nothing. So for the first one here, we can create an async coroutine. It throws an exception, so we try to get the result, but that throws an exception. We can catch it below here. That's fine. And then down here, we can create another coroutine scope block where we do the rest of our work. So yeah, to summarize the error handling tips. Use a supervisor job instead of a job. Cancellation is propagated only downwards, or create a local coroutine scope to group coroutines that are all or nothing. So the code inside the coroutine scope block will inherit the parent coroutine context, but get its own job for independent cancellation. Next tip is to kind of key last one around debugging coroutines. So there are some really good tools around this that are kind of still pretty new. They weren't around when I was doing a lot of this, the first work on this, but they would have been super useful. They still have been really useful. So enabling debug mode. So there's two ways to do this. You can set a system property, or when you see a JVM args, or you can set it programmatically as well. And what does this do? So first of all, it will attach a unique name to every coroutine, so that this gets appended to the thread name for debugging. It's negligible overhead, so you can and should do this in production, or you can manually set the coroutine name as well to give you some better logging. And it'll give you much better stack traces. So normally, or by default, if an exception happens in a coroutine, your stack trace will only contain the stack trace of the coroutine. So if your coroutine is one line long, your stack trace pretty much just contains that, which can be really not that useful. But with this debug mode on, it will piece together the full stack of the different coroutines that were called, which is really, really useful. But there is some performance overhead for this, so it's not recommended for production, but you can enable one but not the other. Next is the debug agent. So just released last April. So really powerful debug capability. So it's a JVM agent that keeps track of all your live coroutines, and it introspects and dumps them similar to a thread dump command. And it'll also give you much better stack traces as well. So if we take a look at an example of this. So this is how you say, start introspecting the coroutines, do debug probes.install, and you do some work, and then you can dump all your coroutines to the console, Or you can just pick one job and say print, give me all the details on that. And the output of that looks a bit like this. So you have your coroutine name, the state of the coroutine, which can be really useful for trying to track down deadlocks. You have the current stack trace of the coroutine as well as the coroutine creation stack trace. Very useful as well. And then if you just want the single job dump, you'll get all the coroutines that are associated with that job, so all of the child coroutines. There's a JUnit rule for this, so if your test takes longer than a second, it'll just dump all your coroutines to the console. And you can also use it as a JVM agent, so just like on application startup, it'll start introspecting your coroutines. Okay, so the last section is on some tips on keeping your coroutines testable and clean that we picked up along the way. So first, essential tip, not specific to coroutines, you need to test everything. Super useful, especially if it's like a new library that you're not really sure how to use. You need to kind of validate, it's kind of the quickest and easiest way to validate that how you assume it works is how it works. And yeah, for unit test, you can just add run blocking to the start of your unit test or run blocking tests, which is in the Kotlin test library that I learned in the last presentation. It's a bit faster. So yeah, really good tip for making your code testable, particularly so only use async at launch when you really need concurrency. So if we take a look at an example of this, so say we have this update data function that calls 3 suspend functions. So we have get data, post data as the user doing network calls, and then we want to update the UI. So this won't compile. We'll get an error saying suspend function get data should only be called from a coroutine or another suspend function. So the temptation here is to just launch some new coroutines that they're cheap to create. I don't really when this finishes, just kind of do it in the background, which works fine. You know, so we launch a new coroutine on the dispatchers or the IO dispatcher. We do our network calls, and then we launch another coroutine on the main dispatcher to update the UI. But the issue with this is it's really hard to test. So you don't know when this function is actually finished after you call it, because as soon as the first coroutine is launched, the function will return. So what you should do here is prefer marking a function suspend to launching a new coroutine. Then in your test you can call this, and you'll know when it's finished, but you'll still get all the benefits of like not blocking in your production code. And in your production code, then you can decide to run blocking or like run it in a new coroutine. So yeah, it allows the callers, as I was saying, to control the context, so where it runs, what thread pool it runs on, and the asynchrony, and to know when it's finished, which is essential for tests. But you should control the coroutine context when needed using the with context block. So for your network request, you need these to happen on the IO thread pool, not on the main thread. But then for updating the UI, you need this to happen on the main thread. So you can use this with context block, which is really a really nice simple way for switching threads. So it'll change to that thread pool, but without launching a new coroutine. So then we have the question of what do we do with functions that launch long-running coroutines. So say we have this function here, launch processing. So it launches two coroutines that we want to just keep running for a long time, doing some background processing or listening. But we don't know, so it's kind of difficult to cancel these or control where they run. So the convention is to, if any function that returns before completing all of its launch coroutines should be an extension method on coroutine scope. So you're essentially passing in the coroutine scope. The caller can then use whatever scope it wants, cancel all of these coroutines whenever it wants. Another option is to make it a suspend function and to use a coroutine scope block. This will behave a little bit differently, so they won't be kind of long running in the background, but the coroutine scope, you won't reach the end of the coroutine scope block until all the coroutines in it are finished, which can be really useful for some cases. So yeah, in summary, coroutines are really awesome. You can write some really nice code with them, but you know, async programming is still tricky. You still have to kind of figure some tricky issues out. And yeah, so I think that's it. The only other thing, so I published a blog post on covering some of this, but as well as that kind of how we moved away from throwing exceptions and using return value result objects instead, which I posted on Twitter yesterday if you're interested. But yeah, so that's it, I think. So thanks very much. Are there any questions?
Just to reiterate, why exactly was they recommended against using global scope launched as, and you said, can you reiterate why it is that global scope is kind of like concluded now?
So it's certainly for Android, you know, in terms of an Android scope, you know, if you're launching coroutines in the scope of an activity, when you kill that activity, you want to be able to clean it up. So yeah, it's generally just so you can clean up the coroutines you launch whenever you do, but if you use global scope, you can't clean them up, you can't cancel them. Well, it's more difficult to cancel them. And if a coroutine hangs for some reason, it'll keep going until your application is restarted.
Thank you.
Okay, cool. Thanks very much.